All right, good morning. Today is Tuesday, March the 31st. I hope that you are all well today. Another fairly short lesson today, although we have a few slides, not just one like yesterday. Um, Section 10.3 in your textbooks is entitled Locating the Center of Gravity. Now, for a regularly shaped object, this is a fairly straightforward and easy thing to find. All you got to do is find the geometric center or the midpoint of the object. All right. I'm going to go back to using my kid's toy here, and if I want to find the center of gravity here, there's only there's only one point where I can balance this thing on one finger. All right, and that's that right there is the center of gravity. If I try to balance it by putting my finger over here, right, it falls. All right, it's not balanced. We're not at the center of gravity. Okay, and so in this case, holding it right at the center, all right, that is where the center of gravity is located. Now, it's more difficult if you're going to talk about something that is irregularly shaped, but it's not impossible to find the center of gravity here. The diagram on the right-hand side of your screen shows an irregularly shaped piece of cardboard or whatever it happens to be. And so what you do is you drill a couple of holes in it and you suspend it from each of the holes. And then you draw a straight vertical line from where it's being suspended toward the bottom. There was a wonderful example of that in the video that you were supposed to watch on Friday in section 10.1. Right, that center of gravity video illustrates how to do this quite nicely. In any event, if you look at the various pictures here, they suspended this thing 3 different times from 3 different holes and drew vertical lines downward. And where the 3 lines cross, that is the point of the center of gravity. Now, interestingly enough, the center of gravity of an object can be located where no actual material exists. All right, and there's a great example of that in terms of what we call donut holes. Now, so that brings us to example number 1 from the textbook, which asks, where is the center of gravity of a donut? Now, the donuts that we're talking about here are ones that are round with a hole in the middle. Okay, and so that hole has no donut material in it. Right, the donut is all around that hole, but there's no dough in the middle of the donut. And so therefore, interestingly enough, the center of gravity is located in a spot where there is no donut. Okay, it's in the middle of the donut, but there's no actual donut material there. All right, and so the center of gravity for a donut or any a wedding ring or anything else that is circular, right? The inside of this little spring, the center of gravity is somewhere in there. All right, but there's no actual metal there. All right, and so the center of gravity doesn't have to be located in a position where you actually have the material. All right. Now, for a solid, oh, Mr. Coleman's texting me. What do you know? In any event, the center of gravity doesn't have to be located where there's actually material. Okay. That brings us to example number 2. Can an object have more than one center of gravity? Okay, well, the answer is yes and no. Okay, any given object at any given moment can only have one center of gravity. So we already did this trick where we balanced the thing, we found the center of gravity right in the middle. But what if I changed its shape? All right, and I turn it around such that it's got a scenario like this. All right, now the center of gravity is no longer in the middle, it's somewhere down here. All right, I'm suspending this from my finger. If I draw a straight line downward, you can see that the center of gravity is located where there's actually no material. It's down here somewhere. All right, and so But to answer example 2, can an object have more than one center of gravity? Not at any given time, all right? But I can move the center of gravity if the object is flexible or pliable, like a ball of clay or even this thing, all right? If I bend it here, it has the center of gravity. That center of gravity is going to be located somewhere right around here, all right? Again, no material, all right, but the center of gravity is here. If I then turn it again, now the center of gravity is probably somewhere around here-ish, all right, based on the weight distribution of the toy. All right, and so to make a short story even longer, an object can have more than one center of gravity, but not at the same time. All right, at any given moment, there's only one center of gravity. Okay. So that's all I have for you today, fellas. You will have a homework assignment, which I will attach to the portal. It will be worksheet 10.1. All right, so spend a little time with that today, and I will collect that in theory tomorrow on April 1st when we go back to school. As far as I have heard at this point, we're still going back to school on Wednesday. So I will hopefully see you tomorrow.